Alright, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College Application and Website Development, or AWD program, and in particular the AWD 1112 Application Programming with Java class, I've been doing a series of video presentations based on the two books for the class. I'm currently in the first book, Java Quick Syntax Reference, and I've done the first 10 chapters of the book, meaning I've got about 12 to go, and actually there'll be more than that because this copy that I have here is a little older, so I'm actually going to do another chapter or two. But I'm up to Chapter 11 talking about static. And what you'll notice if you look here, as it says, the static keyword is used to create fields and methods that can be accessed without having to make an instance of the class. Now, I like to give examples that aren't necessarily computer examples, because I think that they can help make more sense in what's going on here. So let's forget what they say in the book, and for just a couple minutes, kind of like let's suspend our belief and talk about something else. Many years ago, when I taught Java at another institution, I used a book, and I can't remember the name of the book or the publisher or anything else, but what they had in that book, all right, what we did in that book, let me just move, I'm going to leave that there, is you worked with creating a balloon. Now that might sound silly, but what would happen was you would have it on your user interface. I'll make this bigger. On your user interface, like if this was your interface, you would have, oh, let's see, a couple of buttons. Can we make that black? I don't know if we can do that or not. It's been a while since I played around with this, so. But you had a couple buttons. All right. Can I do that? Let's see. All right. All right, I'm just going to very much hand do this. So this was a button. This was a button. This button here said grow. This button here said shrink. And what you had here was a little dot, which represented a balloon. Every time you clicked the button that said grow, the balloon would get 10 pixels bigger. Every time you clicked the button that said shrink, it got 10 pixels smaller. And you could make as many of these balloons as you wanted to. So what does this have to do with anything? Well, every time you made a balloon, they each had their own properties. Just like if you go out and buy some balloons. One could be red, one could be green, one could be blue. One you could blow up like a regular balloon. Maybe you had a magician there, and one of them they made into a dog, one of them they made into a hat, etc. But when you look at this, I think you'd agree, you'd have 3 balloons. So even though each balloon was an entity into and of itself, could have its own color, its own shape, its own, how much air is in it, does it have helium in it or not, etc. There would, if we had a balloon counter, we'd want one counter, in this case, that had a value of 3. We wouldn't want 3 balloon counters that each had a value of 1. So this one value, I could ask the system, how many balloons do I have? And it would say 3. Then I could come through here and I could remove one of them. And now I could say, how many balloons do I have? And it would say 2. All right, so if I made that counter and I wanted to be able to use it and not even worry, in fact, if I wanted to, let's say I got rid of all my balloons. I'd still want to be able to press a button or do whatever and have it say that I had 0, even when there were none. So when something depends on the class, like a balloon class or a whatever class, and it does not depend on objects of the class, that is static. So with static members, there's only one copy. It belongs to the class. It's shared by each object in the class. On the other hand, everything you create that's non-static is its own thing. So let's try to bring this around. Right there, I've got two rectangles. Neither one of them are static. But I'm going to come up here and I'm going to put in static int, and I'm going to call it rectangle count. And I'm going to initialize it to 0. Probably would be anyway, but I don't care. Oops. So now I'm going to come in here and I'm going to say my rectangle 2. Notice if I say dot, all right, well, I thought it was going to show me rectangle count there, and maybe it's not, so we'll see. Huh, I'm surprised. Do we not need that? Rectangle count. So I'm going to come in here and say plus plus. So I'm adding 1 to my counter now. And then I want to do it again after I create this one. So I've added twice to my rectangle count. Right there. Okay. Now what I want to do is I want to do one more S out. And I want to say there are a total of how many rectangles? All right. So we'll again do a save all, and we'll run this, and let's see what we get. There are a total of 2 rectangles, all right, which there should be, S and R. All right. Now this thing where I made this null, I don't need that anymore, so I'm going to get rid of it. If you do that and you add code for whatever reason, you don't need the code anymore. You really and truly shouldn't leave it lying around. All right. It's also known as code bloat, which you don't want to do. All right. Now let's see the example that they gave here. Static methods cannot use instance members since these methods are not part of an instance. On the other hand, they can use both instance methods can use both static and instance members. So what do we have here? We've got class myCircle, where we've got R, which could be a radius or something else, and static pi. All right. And we're returning pi times a times a. And the point is, notice we can use both the static and the non-static member. Okay. I don't know if that's a great example or not, or if mine's better or not as good. Accessing static members. To access a static member from outside of the class, you use the class name followed by the dot operator. From outside of the class. This operator is the same as the one used to access instance members, but to reach them, an object reference is required. What does that mean? Well, you know how I put this plus plus rectangle count here? Let's get rid of it. All right. And where we made this static, I'm not sure if this will work or not. So let's see. Can we come in here and say plus plus? It doesn't look like it's going to be able to recognize that. But how about if we say my rectangle 2 dot? Nope, doesn't like that either. Rectangle count. Doesn't like that. All right. What if we came in here and made this public, all right, rectangle count. Now, can we come in here and say plus plus, oops, plus plus rectangle count. So I'm not doing a very good job of selling this to you right now. All right, now I'm going to remove that. This is my take. All right, so I'm going to give you my take on using these. Okay. Rectangle counts. All right, and that is this, that when I have variables, and if those variables, right now everything we're doing in main. In just a little bit we'll start breaking main up into other methods. All right, if I have variables that are going to interact directly with main, okay, and I want to define them outside of any routine, they're going to be static. Now, again, that's my take, not nearly as good as our authors, so let's look back at our authors. The advantage of static members is that they can be used by other classes without having to create an instance of the class. Fields should therefore be declared static when only one instance is needed. Balloon count, like I told you, or rectangle count. A good example of this, probably a better one than the one I used, would have been to use the math class. You can say double pi equal math.pi. You do not have to create an instance of the math class. You don't have to create a math object. You're saying from the math class, there should only be one thing in there, one constant called pi. Copy that value to our local variable called pi. So it says here, math is one of the classes that are included by default in every Java application. The reason for this is because it belongs to the java.lang package. That is automatically imported or brought into every Java program without you having to do anything with it. All right, not only can you have static methods, you can have static fields. Static fields, unlike non-static fields, you use them, and once the method is over, they're gone. That memory is given up. Static fields last as long as the program lasts. All right, and their example here is similar to the one I showed you. All right, you only have to initialize a static field once before you ever use it, and then it'll maintain that value throughout the life of the program, unless you reset it to something else. You can have a static initialization block. I don't use these very often, if ever, but as it says, it can be used if the initialization of static fields requires more than one line. A static initialization block is only run once. It allows you to initialize a bunch of things at one time. Okay? There's also not a static initialization block, which starts with the word static, but a non-static or an instance initialization block, which, as it says, provides an alternative method for assigning instance fields. All right? And a class, as mentioned, can have multiple initialization blocks. Looks like that's it for static. And I'm right here, but it's just about finished with the last one that I was working on. So I'm going to let this finish up. I have to delete this so I can include this. And I will be back with the next chapter. So I can now delete this and this. Be back soon.